Hello, my name is Rob Reynolds and welcome to College Algebra. I'm going to be discussing in this video section 1.1, linear equations. This will be a little bit easier than the factoring section that I did previously on the review section. So today we're just going to take a look at a couple concepts that discuss that I can add, even though they have parentheses here, I can add the 2 and the 6 and get the plus 8. Here I can add the 2x and the x for a total of 3x. So they're just showing you how to combine like terms to simplify before you actually solve the equation. Down here, we're simply saying that you can add 5 to both sides and it's equivalent. This next example, they're saying you could multiply both sides. So you can add or subtract to both sides of the equation. You can multiply or divide. You can do anything you want to an equation as long as you do it to both sides. On this next slide, they're actually asking you to solve. And some of us know, please excuse my dear Aunt Sally. I like to try to look at this as you do the multiplication and division at the same time, but you do it from left to right. So we'll extend, please excuse my dear Aunt Sally, to please excuse Mada as, add and subtract, from leaving the room. So you do the addition and subtraction at the same time from left to right. That way we don't end up with poor answers. For example, if you have 100, let's go divided by 2 times 10. According to, please excuse my dear Aunt Sally, some people think that we should do the multiplication before the division because m comes before the d. If you do that, you'll get a wrong answer because you do not do the 2 times 10. You do not want to end up with 100 here divided by 20. You'll end up with the wrong answer. 5 is not the correct answer. So you should be doing this from left to right. 100 divided by 2 is 50, and then you multiply by 10 for 500. So continue to discuss, please excuse my dear Aunt Sally, this is the order that we do things in. So you start with the parentheses. I am going to be solving, so I'm going to be talking about the way that we undo things. So we do the parentheses first, we do the exponent second. If you're going to undo, the first thing that we undo is the addition and subtraction. This doesn't work all the time. There are exceptions to this rule, but the first thing I'm looking at here is to undo this minus 7 by adding 7 to both sides. So 4x is equal to 20, and then if you divide by 4, x will equal 5. In the next example, again, I'm giving you some rules. Here's the book's rules, which are kind of lengthy. My rules say, well, let's go ahead and simplify or combine like terms first. The second rule is to get all the variables on the same side. I do have a hint here. The hint for this is get rid of the smaller variable. And I'll show you an example of what I mean by that. If you have 2x on the left and 5x on the right, let's get rid of the 2x. Then we add or subtract, sorry, and then you multiply or divide. So for this one, here's the exception to that rule that I was telling you about. According to, please excuse my dear Aunt Sally, you would think I'm going to undo the addition and subtraction first, but in this case, you do not want to add 5x. This is the exception to the rule. You'll probably want to multiply both sides by 2 and then distribute that to every term over here. So again, that's showing you there are exceptions to these rules. For this one, I would recommend clearing the denominator. It looks like the common denominator here is 12. Some of you are going to try to do this the hard way and just take 1/3 and start distributing. And again, that's doing. I wouldn't recommend doing when you're solving. I would recommend trying to undo. So I'm going to undo these fractions by multiplying both sides by 12. Then I'm going to distribute this 12 to every term. And if you don't know, I'd like to point out too that there are 2 terms on the left side of the equation. So it looks like I multiplied the left side twice by 12, but I did not. I multiplied this side by 12 only once and then distributed that 12 to both terms. And this side, there's only one term, so there's only one 12 on this side. So after we distribute, I'll cancel. 12 divided by 3 is this 4, and the 4 is actually what gets distributed here. So I end up with 4x minus 4 minus, and then I'm going to multiply 12 times 3 to get 36, and it will equal, I'm going to cancel this 12 and this 4 again for a total of 3, and I'm going to distribute this 3 to both of these terms. for a total of 9x plus 6. Then, following my simplifying rules, the second rule is after I distribute, I want to combine like terms. So I see some like terms on the left side. So before I start trying to get all the variables on the same side, let's go ahead and combine terms for a total of negative 40. Then I'm going to look at the x's and try to determine which x value I should get rid of first. Here's a 4x here and a 9x, and again my hint is get rid of the smaller. So I'm going to get rid of 4x by subtracting that off. If I subtract off 4x from both sides, negative 40 is equal to 5x plus 6. Next I'll subtract off 6, trying to isolate the 5x. For negative 46, and last, if I divide by 5, I'll just leave these in fraction form. Don't try to change this to a mixed number. I prefer you to leave these. I know you spent a lot of time in grade school trying to simplify things like this, but I would leave this is the exact answer. Don't round to a decimal, just leave the exact answer and leave the improper fractions. For this one, I won't work it out, but again, I'm looking at clearing the fraction, so I would get rid of this denominator, and I'd multiply every term by the common denominator, which is this 12.231. And it does say use a calculator, but again, to do this, it's 12.231 times this term, 12.231 times this term, and 12.231 times this term. And of course, this will cancel, just leaving me with a 4. I would use my calculator to calculate the rest. On this one, I'm going to do the FOIL method. Some of us remember the FOIL method, standing for first, outer, inner, last. So my first terms are 3x and x for 3x squared. The outer terms are 6x. The inner terms is negative x. And the last term is a plus 2. On this side, I'll do it again. 3x squared minus 2x plus 9x minus 6. And then I'm going to try to get all the variables on the same side. And fortunately for me, it looks like some things cancel, because if I subtract off 3x squared from both sides, they're gone. It looks like I can combine some terms here, so I'll bring down the next step for a total of 5x plus 2. And that will equal 7x minus 6. So again, following the rule, the smaller is the 5x. So if I subtract off 5x from both sides, add 6 to both sides, and divide by 2, I get x equals 4. Later we'll talk about checking for extraneous solutions, extra solutions, but I think those will work. This one's a little bit more complicated. Again, I'm looking for a common denominator. I don't like the fractions, so I need to pick a common denominator, choosing every factor as many times as it appears in each denominator. So it looks like I've got x minus 1 as a factor and x plus 3. X is not a factor. I'm going to choose the whole. You can think about this being in parentheses. So I'm going to choose x minus 1 and x plus 3. And I'm going to multiply every term, just like I did before, multiplying every term by the common denominator. And this time I'm going to have 3 terms, so I'll have to write it 3 times. This time, the only thing that will cancel over here is the x plus 1s. Here, the x plus 3s will cancel. And then here, everything down here will cancel with everything up here. So, what am I left with? I'll distribute this 2 to both of these terms for a total of 2x plus 6 is equal to 3x minus 3. That's distributing this 3. And the only thing left over here is a plus 1. I'm so sorry, this is a plus sign here, so I'll bring that plus sign down. So, combining like terms, it looks like I have some like terms on this side. I need to combine the negative 3 and the plus 1. So, I'm left with 2x plus 6 is equal to 3x minus 2. I'll subtract off the smaller, 2x, add 2, and x will equal 8. Again, that doesn't cause me to divide by 0, so I'll assume that that's the correct answer. The common denominator this time is x minus 2. So I'm going to multiply again every term by x minus 2. Again, it looks like I multiplied the left side twice and the right side once, but I did not. I just multiplied both sides and then distributed to every term. Over here, everything cancels except for the 3x. This side, I'm going to distribute the 1, leaving me with x minus 2. And the only thing left over here is 6, for a total of 4x minus 2, or 4x equals 8, or x equals 2. Still getting used to my new mouse wand. For this one, we've seen this definition before. To evaluate the conversion of Fahrenheit to Celsius, I'm going to try to identify if this negative 10 is the F or the C. And since the directions are, what are the Fahrenheit temperatures, what are corresponding to, these are the Celsius. So I know C is equal to negative 10 in this first example. So they're asking me to solve if I let negative 10 equal 5/9 F minus 32. So I'm going to have to do a little bit of work here to solve, and to undo a fraction, instead of dividing by a fraction, you can multiply by the reciprocal. So I'm going to multiply both sides by 9/5. And what that accomplishes is this 5 will cancel and this 9 will cancel, leaving me with just F minus 32 on the left side. On the right side, I need to multiply. And again, let's leave it negative 90/5, or that simplifies to negative 18. And lastly, I'll add 32. And here's my conversion. You can go ahead and do this for the 0 degrees and the 40 degrees as well. But again, the goal here is the process is the same. So here again is the books. Read the problem. For word problems, you've got some variables to define, draw a picture, and write an equation. Let's see if we can do a couple together. The first clue that we have here is saying $16,000 is invested into some stocks and some bonds. So I'm going to try to write that equation out by saying some stock and some bond is equal to $16,000. The second clue comes from the sentence that says bonds is 1/4 that of stocks. So I'll try to write that sentence out as bonds, being B, is means equal. So we've learned two things here. And means to add, and is means equals. Bonds is 1/4 that of stocks. So I'm going to try my substitution method, and I'm going to let my bonds equal 1/4 that of stocks. So I know that every time I see a B, I'm going to plug that in as 1/4 S. So I'm going to rewrite this top sentence, but instead of saying S plus B, I'll say S plus the B value is 16,000. And now I know that the B value is 1/4 S. And if I add 4/4 plus 1/4 is 5/4 S. I'll multiply both sides by the reciprocal for 4/5. I'll get everything canceling over here except for just S is equal to 12,800. And the last thing I'd like to do is maybe plug that back in here. So I know 12,800 plus my bonds is equal to 16,000. And I'll solve for the bonds, which is around 3,200. So a couple answers. Again, the last example that I have here for you says that Andy's going to work for 50 hours, but for 40 hours he gets regular pay, and for 10 hours he's going to get time and a half. So we'll break this up. For 40 hours he's going to get regular pay, $40 times X, plus for 10 hours he gets 1.5X, and that's going to total his $440. So we'll multiply this out. 40X plus 15X equals 440. So 55X equals 440, and he's going to make about $8 an hour. I hope that's helpful. See you later. Bye.